So 8.1, 1 is dimensional analysis, 2 is atoms, 3 is AMUs or atomic mass units if you prefer. 4 is to multiply some stuff first, and then we're going to add it all up. So the 5 blanks are dimensional analysis, atoms, AMUs, multiply, and add. Question about storing things up. Are you all done? Yeah. You sleep there, okay. So here's what this chapter is about. This would be quantitative chemistry, to use a word from the Wayback Machine in chapter 1. Does anybody remember what quantitative meant? Yeah, it's just how much is there? So at some point that'll be a bonus question, not tomorrow, but if you want to jot down bonus question, quantitative equals how much, that's the name of the game. Next quiz, you'll read 8.2. 8.2 has two or three new points. Three new points. They did a better job in this new one of really like highlighting what was important. So when you read 8.2, it's not going to be as much of a mystery as 8.1 where there wasn't stuff in the margins or bolded or so much. Some of it was italicized, I think. But it's the 3 words in 8.2 is going to be a little more obvious. So take about 4 fill-ins. So 4 fill-ins and 3 lines for 8.2. Then changing today's a little bit, it'll say we're going to do a lot of calculations in this chapter using the blank method of problem solving, which is dimensional analysis. So in other words, number 1 stays the same. What was dimensional analysis?
The thing that it's like the yeah, it's like a line, and then there's like divisions.
So it's like
then,
that thing.
Yeah. You
start with
across.
grams, and maybe you change that to kilograms. And then you change out kilograms to get pounds. And maybe you have to keep going, or maybe you don't.
And then you multiply all the ones on the top.
Multiply everybody on the top, divide everybody on the bottom. So that's back. We haven't seen that for a while. But that's back, and that's back strong. Not today, but soon. Instead of doing all this stuff with 2, 3, 4, 5, I'll ask you a question. How do you find the molecular mass or the formula mass of a compound? So maybe I should do this. There's 3 masses we care about. There's a thing called atomic mass. There's a thing called molecular mass. And there's a thing called formula mass. And you're not going to really tell the difference one to another when you're doing math with this. The technical difference is atomic mass is unsurprisingly the mass of an atom, whereas a molecular mass is the mass of a molecule. And the formula mass is the mass of a different thing that we talk about less, called a formula unit. Okay, so there's formula units, there's molecules, there's atoms. They're all measured with the same measuring system, which was, what's the unit called? Not inches and feet and seconds and hours. AMUs stands for atomic mass unit. Where can you find these AMUs most conveniently?
Inside the book? Covered?
Where? Yeah, as part of your periodic table. It's the whole numbers or the decimal numbers? The decimal numbers. The decimal numbers are the atomic mass of each atom. The whole numbers are called what? What were those called? The 1, 2, 3. Hydrogen's 1, helium's 2. Those are the atomic numbers. So the 1, 2, 3, 4 numbers on this table, those are the atomic numbers. Those count the number of protons. And protons have a mass of 1 AMU. Neutrons, mass 1 AMU. So they're usually about double-ish. The atomic number compared to the atomic mass is usually about double, because the protons and the neutrons are usually close. Why do the electrons not really factor into these masses? Mass was negligible, meaning it has some mass, but it's like so puny that people hardly even care about it. But these are all measured with AMU. But technical differences, is this a description of an atom, a molecule, or a formula unit? That is an atom. So this would be an atomic mass. Atom, that's an atomic mass. We would get those straight from the table. That's a molecule. We'd put, when there's 2 of them, what was the word for 2? Di something. There's 7 of them.
Oh,
Let's name the 7.
IONHF.
Diatomic. This would be a diatomic molecule. There's 7 of them that are always diatomic. You never breathe in O. You always breathe in O2. There is no O. As soon as O gets near another O, it's like O2. So that's a molecule. It's another molecule. So this must be a formula.
Formula unit.
What makes this be a formula unit? Why is this different than the others?
2 molecules.
Where have you seen Na before? Where have you seen Cl before? And you have not seen C in this location.
Ions.
Ions. Sodium has a charge of +1. Chlorine a charge of -1. So the charges, they get together, they work that out, electrons and all that. Carbon? Ions? Not there. Okay, so this is something that we'd be doing a whole other way. So these are molecules because atoms are bonded together different ways. This is a formula unit because it's got the positive ion, the negative ion, you put them together. That's what a formula unit is about. But in terms of your math, the math is going to be all the same. So here's the question. How do you figure out the molecular mass or the formula mass of a compound? So let's just do one. What is the subscript count? How many atoms there are in this? This is a formula unit, but it doesn't really matter to us because that's positive and that's negative. How do you suppose you'd map this up to figure out the total way I'm using this thing?
Multiply it by 2.
You take 2 times,
It's 22.99.
so we're going to round to usually 1 decimal place. So was it a 0.99?
Yeah.
We'll just call that a 23. Sulfur?
4 times.
Not for sulfur.
No, it's just. The
Oh, it's-
number. I
yeah, it would
can't
just
find
be-
it. What time? It's 32.1.
32.1 because it's a 32.06 on the
Oxygen
table.
would be 4 times.
Oxygen would go 4 times.
Whatever the number is.
Whatever the number.
15.99.
So if it's 15.99, we're going to call that 60. And then we're going to do what?
Add them all together.
Add those all together. So if we're trying to put this into words for a vocab question, what do you do?
Counting like the number of elements, multiplying them by their component.
Sort of, yeah, we're sort of close to that. So
The amount of atoms by the.
how do you know the
AMU,
amount of atoms?
The subscript
Okay,
of the AMU of one of those atoms,
okay.
and then add all of them.
I like to add them all up. So here's my answer I'm going to go with is for each element, multiply the number of atoms from the subscript by the mass in AMUs. Okay, so I don't know what we missed, but we think this is 142.1. If you missed some quiz preview, the final thing we said, it's a 10-point quiz tomorrow, so rerun that 8.2 thoughts. It's 4 new points that are more obvious from the reading. 5 is today, same as 1. 6 is a sentence for every element. We're going to multiply the number of atoms from a subscript times the mass in AMU and add them up. That's what we're about to do 2 more times. And then it's a 4-point explanation that molecular mass is for compounds that are molecules, and that's covalent bonds. And then formula mass is compounds existing as formula units and being ionic bonds, but with an emphasis that the math doesn't change. So this is technically a formula mass because this is a positive and a negative charge thing coming together. This is technically a molecular mass because it isn't that, but just do the same thing. Again, for every element, we're going to multiply who?
The amount of atoms.
The amount of atoms, which for carbon is 12, times AMUs, which for carbon periodic table is 12. Then we're going to take hydrogen, there's 22 times 1. Oxygen, there's times 16. And if you memorize some of these numbers, it's going to speed up. Math time. 176, 144, 2342. Use. All that. One more time. They're all the same. This one's, I guess, a little different because of the parentheses changing things. So for calcium, there's 3 times, look it up.
40.
I think it's 40.1.
Yeah.
Then phosphorus, there's
2.
2. Because there's like a distributing chemistry problem going on here. The 2 is multiplying all of these. So there are 2 phosphorus. I don't remember phosphorus.
It's 31 if you're on it.
31.
It's 31.97. 30.97.
30.97, so we'll round that to 31. Oxygen, there'd be a total of 8 times 16. Add that all up, 28, 2, 190, 310.3, I think. Yep. Use. We're not going to obey the significant digits or anything on this. All those rules are out the window. We're going to round these to the tens place, so the answers will be rounded to the tens place. We don't care how many digits there are. Question about 8.1 and the math and the things that are happening there. So 8.2 quiz only goes to 10. Homework off of this 8.1 is a 2A and then also 3 and 4. 2A, I'm sure, is some sort of vocabulary retread. 3 and 4 is, there's 6 in each. They go A, B, C, D, E, F, because you know how they like to fool you. So we did 3 of these masses. You're going to do 12 of those masses in 3 and 4. We're going to continue to score these on the 20-point scale. So if that's done tomorrow, that's a 20. Every day after that, go down by 2. But that is about it. Question on any of that?